Hi, my name is Mr. Evangelista, and welcome to another episode of Evangelist Science. Today we're going to be writing chemical equations. Let's get started with this one. We've got silver plus chlorine will give us silver chloride. So silver is Ag on the periodic table, and chlorine is Cl on the periodic table. Now, remember we always have to check if any of the elements that we write are Brinkelhoff elements, which means that they come in groups of two. We see silver is not a Brinkelhoff element, but we see chlorine is. And so chlorine has to come in twos when it's alone. This gives us silver chloride. Now silver chloride is a metal and a nonmetal. It's an ionic compound. And so to write the formula, we have to look at the charges. Silver is +1, and chlorine is -1. Now I got this question today. It says chloride, not chlorine. Mr. E, why are we looking at chlorine? Remember, when we're writing ionic compounds, you write the first element like normal, and then you write the second element, but you replace the ending with IDE. That's how you name ionic compounds. Since the charges are 1 and 1, we only need 1 silver and 1 chlorine. And so this is our formula for silver chloride. Now why is it not AgCl2? Remember, it's a Brinkelhoff element. Why is there not a 2 here? Well, Brinkelhoff only applies when the element is by itself. This chlorine is bound to something, and so it does not need a 2. You only need a 2 when the Brinkelhoff elements are by themselves. This is a synthesis reaction, so it's A plus B gives us AB, two things coming together to make one. And let's balance it. I've got 2 chlorines on the left, so I need 2 chlorines on the right. And that gives me 2 silvers, so I need 2 silvers on the left. Good. Let's do another one. We'll do 5 of these today. So number 2, zinc plus fluorine will give us zinc fluoride. Zinc on the periodic table is Zn, and fluorine on the periodic table is F. Any of these Brinkelhoff? Yes, fluorine is a Brinkelhoff element, so we need 2 of those. That gives us zinc fluoride. Now zinc fluoride is a metal and a nonmetal, and so zinc has a charge of +2, and fluorine is a charge of -1. So the charges are not the same, so we would have to use the crisscross rule here, where zinc gets the 1 and then the fluorine gets the 2. They switch. So we do not write the 1, but we do write the 2, and so we get ZnF2. This is a synthesis reaction because it's 2 things coming together to make one thing. And it looks like it's already balanced, so no balancing to do there. The next one, potassium chlorate, gives us potassium chloride plus oxygen. So potassium chlorate, we've got a metal and a nonmetal here. So potassium is a group 1 metal, so its charge is +1. Now what is chlorate? It's not the same as chlorine or chloride, so we cannot just use this chlorine for this one. In fact, we have to use our polyatomics. Remember these guys? This is the list of polyatomics that was given to you that you needed to know. So chlorate is right here, chlorate. It has a formula of ClO3 and a charge of -1. So let's put -1 there. We've got 1 of each, so they're balanced. So we need 1 potassium and 1 chlorate. So the formula for potassium chlorate is KClO3. This will give us potassium chloride, again another ionic compound, a metal and a nonmetal. So potassium is +1, and then chlorine is -1. I can use this chlorine because it ends in IDE. So +1 and -1, so they're already balanced, so I just need 1 of each. Plus oxygen. Remember, oxygen is a Brinkelhoff, so it comes in 2. This is a decomposition reaction because it's one thing breaking apart into 2 things. And let's balance it, so there is no way that 2 can ever go into 3, so we would need to double this side. That gives us 2 potassiums and 2 chlorines, so let's add a 2 here. Now I've got 6 oxygen, so I need a 3 here. Perfect, almost done. Dichlorine heptoxide gives us chlorine plus oxygen. Now this compound right here might sound scary, but it's not too bad. Let's break it down. We've got chlorine, and we have oxide, which is oxygen. So we've got chlorine and oxygen. And remember, we just need to look at our prefixes to figure out what these words mean, to figure out what they are. So di means 2. So that means we have 2 chlorines. Hept is 7, which means I've got 7 oxygens. And that's it. Now, this is going to give us chlorine plus oxygen, which are both Brinkelhoff elements, so we need 2 of them. This is, again, is a decomposition reaction because it's one thing falling apart into 2. Let's balance it. The chlorines are good, but oxygen comes in 2s, which can never go into 7. So we'll need to double this side. That means I've got 4 chlorines, so let's balance it on the right with 4 chlorines. I've got 14 oxygens, and so I would need a 7 here to get 14 oxygens. Last example. We've got potassium plus zinc nitrate gives us potassium nitrate plus zinc. So potassium is K. It is not a Brinkelhoff, so we'll leave it there. And we've got zinc nitrate here. Zinc nitrate is an ionic compound, which means it's got a metal and a nonmetal. So zinc is plus 2. Nitrate, it's not nitride, so we cannot use nitrogen. We would have to look at our polyatomic ions. Nitrate here is NO3 minus, so it has a charge of -1. So that means I need 1 zinc to do, if I'm doing the crisscross rule, I need 1 zinc and 2 nitrates. That means that, remember, these polyatomic ions have to stay together as a group. So if it ever gets a subscript greater than 1, you need parentheses. So NO3, and then a 2 there, okay? Good. Let's write the formula for potassium nitrate. Again, a metal and a nonmetal. Potassium is +1, and then nitrate, again, is a polyatomic ion, which is NO3 -1. Here I've got even amount of charges, and so I just need 1 of each. And notice I did not need the parentheses when I only had 1 NO3. When you have more than 1 NO3, you need the parentheses. And we add zinc. It is not a Brinkelhoff. This is a single replacement reaction where we've got, originally the zinc was with the nitrate, but in the end the potassium is with the nitrate. Let's go ahead and balance this. It looks like everything's balanced except for the NO3s. So I need 2 NO3s on the right. So let's put a 2 here. And that means I need 2 potassiums also on the left.